Okay, so hello everyone. Good afternoon, good morning, wherever you are. Thank you all for making time to join us today. We would be starting shortly. So, first of all, today's facilitator goes by the name Professor Samuel Obeng, who is an assistant professor at Warwick University here in the UK. And we are so much grateful for him making time to join us and facilitate the session. His research interests are mainly political economy, public finance, physical transfer, and we hope to learn more from his expertise. So, Professor Ben, over to you. Thank you.
All right. Thank you very much. Thank you, Vanessa, and a big thank you to you and Kingsford for the invite. I hope you can hear me clearly. Great. And I must say that the timing of the sessions have been great from DID to IV to RDD. I think it's perfect. And I should say that of all the causal inference methods, I would say that RDD is to me, the simplest, the easiest to understand and appreciate, and applicable on all fronts. So the source of the whole idea is from psychology. So it's not really an econometric idea to start with. So, and it's applicable. So unlike other methods where you need to think of an IV, or you need to think of a before and after effect and all those things. This is quite simple and straightforward. So I hope I can make it as simple as possible because that's the idea. I want to make it as an applied method. And so forgive me, the econometricians are around if you don't see too much math for those who love it, but I hope to make it a bit more straightforward for most of us. So let's just get into it. So basically, that's my name, and I I appreciate the time. So I'll just get on straight with it. Hopefully, you can see my screen. Can you? Okay, great.
Yeah.
Can you see my screen now? Okay, great, perfect. All right, so the idea basically is to review the RD design, regression discontinuity design, look at the two main parts, which is the sharp and the fuzzy RDD, and also look at a few applications with examples, and hopefully we can talk through some of these examples. So throughout, we would notice that at every point in time in human behavior, there are rules, right? So there are rules governing anything. So, for instance, there's a legal drinking age. There's a legal level that you should be intoxicated when you drive, right? There are also laws concerning things like how you can get access, so scholarships, getting access to particular universities. There are always cutoffs and rules around that. And also, for instance, if you look at public policy in general, right, things like public goods allocation sometimes depends on voting and voting outcomes. For instance, a simple rule would be that to reduce congestion, if for a particular local area, if the population is of a certain level, government will allocate more funds to them, right? Those are all rules. And the beautiful thing about rules is that they then provide us opportunities for research, right? Because then they set the tone for a natural experiment. So basically, RDD is built around rules. As long as there are rules, then you can use an RDD. So these rules could even, for instance, and giving a patient for maybe access to blood pressure medication will simply be dependent on whether or not the systolic is above 135, for instance, right? That increases your chances of getting blood pressure medication, for instance. So those provide opportunity for an RDD. And basically, as long as you can clearly say that people naturally fall into any of the sides of it, so whether they are treated, as you always say, or in a control group, as long as there is no bias in selecting. So, for instance, someone with 136 may not be able to run to those with a systolic less than 135, right? As long as it is clear and there are no ways that people can manipulate the system, then it provides a perfect opportunity. Given the example of For instance, the grades. Teachers may not have to remark and push someone at 194 to probably 195 or 196, things like that, right? Okay, so let's look at the intuition behind it. So usually we say that a variable, so let's look at this graph. We say that a variable x would explain y, right? But so let's assume that there exists another, so look at graphs A and B. Let's look, say there exists D, such that X provides treatment to D. What could that treatment be? I mentioned access to alcohol at a certain age. So let's say that your age determines whether or not you qualify to drink, right? So age, which is X in this case, right? Then has an assignment of D, which determines whether or not you qualify to drink. And let's say Y, the outcome variable would be the propensity or the probability of getting into an accident, right? Or driving related deaths. So we say that when you are younger than 18, you don't have access to alcohol. So we can say that alcohol related death beyond a certain age for young people would be because of that. So we say that there's an allocation simply because you attain a certain age. So looking at the first graph, I will say that let's consider that X assigns people into whether or not they qualify to drink or they don't. And let's say the cutoff for that assignment is the age of 18. So when you're above the age, you attain or you're above the age of 18, you are legally allowed to drink. And if you're below that, you're not allowed to drink, right? So that's basically it. Now, we also say that that assignment variable can affect y. So of course, x is explaining y, which is the outcome variable. And it could also be related to other external variables that may affect Y. So for instance, your peers, people around you, family habits, things like that. All those things are outside of your age and you getting involved in an accident, but could still influence the probability that you're involved in an accident. So driving alone versus driving with peers, peer influence may mean you may want to speed up, things like that, right? But what we say is that the effect you are looking out for should only be coming from the fact that you attain the age of 18 and you are allowed to drink. So treatment is not determined by any other factor outside X itself. Basically, that's the idea. Okay. So we say that X, because you can observe it, right? And then it causes both D and Y. Given that there is a cutoff, then we can easily examine the effect of that cutoff. Right? So what are we doing? We are looking at the effect of being allowed to drink on the probability that you'll be involved in an accident. That is basically the idea. So we can observe everybody's age, but as long as we are able to clearly allocate them to those who have legal right to drink, as in those above the cutoff, that would be to the right, or do not have legal right to drink, those below the cutoff, that would be to the left, then we can include an RDD. So basically, that's the idea of the RDD. Okay. So when we go back to B, you can see that this arrow is now missing. So we are now saying that the explanation of X for Y is simply because one is allocated a group of treatment or no treatment. So the closer you get to C naught, which is the cutoff, the higher the likelihood that you are assigned to the treatment group, and then the higher the likelihood that we could explain your outcome given the treatment that you received. So basically, that is the idea. So then we say that you can identify the causal effects given the cutoff that you have. So the closer you are, the higher the likelihood that you would receive the treatment, right? Okay, any questions so far?
I
Okay,
don't think so.
all right. I'm happy to take questions as I go along. So let me just put that across. All right. But the most important assumption we make is that every other thing, so there shouldn't be any other factor explaining the relationship that you're examining. So the cutoff itself cannot be endogenous. So basically that's the idea. So we assume on the null that everybody is continuous. So all other characteristics surrounding the individuals are the same, whether or not they receive treatment. Basically, that's the idea. Now, as you go forwards, I will explain why we reduce, if I can use that expression, reduce that idea to those around the cutoff when we talk about things like bandwidth. So as long as we can keep all other things the same and they are not explaining anything outside of what we consider as a reason for the outcome that you're finding, then we can say that the jumps are um due to the treatment that we have. And what do I mean by jumps? I'll show you a graph of the jumps. All right. So basically, again, like I said, if people cannot self-select into whether or not they are treated, then X as in age becomes a randomizer. So what we are basically saying is that if people cannot manipulate, then age simply determines whether or not one receives treatment. So selection into treatment is randomly allocated. Basically, that's the idea. Okay. Now I've mentioned a lot of things. So running variable here or an assignment variable would then be, for instance, I've talked about blood pressure, I've talked about age, I've talked about, so if you're looking at voting and elections, for instance, we can say that if you vote for a particular party, you're aligned with that party. If you don't, you're not aligned with that particular party, right? So then what would be the running variable here? That would be if you say that you need 50% to win an election, then the running variable would then be the margin of win that you have, right? And then whether or not you are assigned would be whether you're aligned or not. You voted more than 50%, voted less than 50%, right? So then that would be, then the cutoff would then be the 50% vote margin that we are talking about, right? That would be the cutoff. So those to the right that voted more would say that they are aligned. Those that voted less than 50%. So if you had less than 50% of the vote in a particular region, then that region is not aligned to you. Now, when we come to the bandwidth, we are looking for people around you. So those are barely. So would there be a difference between, say, a party that won a particular area by 51% versus when they lose it by 49%? Is there a difference between someone with a systolis of 136 versus one with a systolis of 134? Now, if we strictly go by the book and say that all those above and all those that below, then we go by the cutoff. What if we consider those just around? So what could happen is that there may not be much of a difference between someone who has 134 and 136 systolis, for instance. For instance, they may be of the same age, same height, same weight, for instance, right? But there are likely to be greater differences for someone who is very far away. So let's say a systolis of 170, 180 is likely to have a higher weight than someone with a systolis of 130, for instance, right? So if we can impose a restriction to consider those around the cutoff, that restriction then becomes what we call the bandwidth. And we say that if you take any two individuals, for instance, one with 134 and 136, like I said, they're likely to be of the same, you're likely to find probably smaller differences between them. Those differences disappear as the number of those closer to the bandwidth or closer to the cutoff increases. So for instance, if you take one person who is 134 and one person who is 135, they may be two kg weights apart. But as you increase it to 1,000 people, the differences might be closer. So basically what we say is that as long as you have a higher bandwidth, sorry, you have a higher sample size of population, the bandwidth could be smaller because you still have people around that you can estimate. So basically, what's the idea of the RDD? You have a rule that likely allocates people into treatment or no treatment. Now, there are people who are closer to or barely treated or not treated. Can we estimate for all those barely treated and not treated within that particular bandwidth to see if the outcome we are looking for would be different? So then we call it a local average treatment effect because you are just concentrating on and around the bandwidth. So that's basically the idea. So basically, what does RDD do? So you account for the running variable and how it affects the outcome. You look at observations around the cutoff and inside the bandwidth. And then so you're comparing those that are just treated against those that are just untreated. That's basically the idea. Now, when I show a sharp RDD, for instance, and we see the equations, I will explain that one of the questions you usually get is how is this different from a fixed effects estimation or an OLS with a dummy. So I'll explain that as we go along. So basically, to do an RDD, you just need a rule that predicts outcome on each side, and you need a bandwidth. That is basically RDD. So from here, you can even exit the meeting if you would want to, because that's basically the idea without getting into the technical details of RDD. A rule that splits people on either side, and you need a bandwidth if you want a bandwidth. And this is why it becomes applicable on different platforms and not just in economics. So let's look at an example. So a picture always helps us. So let's say you have a raw data, right? And you have a scatter plot of that raw data. So for instance, in section A, panel A, you can see that all this is the data, that's a scatter plot of it. And let's say the dotted lines here, the straight line, gives you the cutoff. So you can see that there are observations to the right of it and observations to the left of it, right? So all these are the raw data. You can also see that, of course, it's positively sloped, so it's upward sloping, which is great. Now, what if we predicted it? So using the cutoff, right? So we determine the probability of receiving a treatment and we predicted it. You can see that there's a jump here. Initially, you can't observe in the raw data, but now you can see that there's a jump. So people are not just on the right side. There's a reason for them to be on the right side, which is explained by the cutoff. So as long as you are above that cutoff, you are on the right side. And as long as you are below that cutoff, you are on the left side. But we can't observe that here. So then what is our interest? Our interest now is to look at those around here. Like I said, if you go further here or further there are likely to be more differences on these sides. But observations around here are likely to be closer such that there are barely any differences if there's any, as long as the sample size gets bigger. So what do we say? We say that, yes, these ones are different. So of course, if you go very far away, there's no point examining. Now, if you want to test the actual effect of the treatment, then let's consider those that are barely treated and those that are barely not treated. By doing so, we are able to determine the effect of the treatment itself. So then that gives us the bandwidth. Then with that bandwidth, our estimation would then be what we estimate, because you can see that the jump exists over here. And these are the observations around the bandwidth that you're interested in. So again, that is our RDD pictorially explained. Okay. So I've explained this idea. So let me just go on. So let's look at some examples. And these are examples from papers that exist. So for instance, suppose that you want to know the probability of being arrested driving while intoxicated. And we say that jumps above 0.08. So if you have a blood alcohol count above 0.08, when you are caught, then you are likely to be arrested. So then that becomes 0.08, then becomes the cutoff point, right? And then that Hansen examines the effect of this. Now, for another example, for instance, there's a social welfare system such that there's a national healthcare insurance, and we say that's available for those retired or old age. And let's put the age required at 65. So what that means is that anybody above that age would receive the healthcare insurance. Anybody below it would not receive. So if you are looking at the effect of that on, let's say, their health outcomes, then the probability then becomes the cutoff that you're interested in. So for instance, another one would be Jacob and Levkin, where they examine whether or not a student attends summer school, and they use the grades that the student gets, so whether you fall below or above it, to determine that. Now, and these are for those of us back in Ghana, probably can say that getting into medicine at KNUST, for instance, the depends on you obtaining aggregate 6 in WASI, right? So then that gives you, for all those who are 6 and above, there's a probability that they could get into medicine. So you can see that on various fronts, RDD could be used. So you are not looking at a before and after effect. We are looking at the effect as long as there is a rule. Basically, that's the idea. And then you can get into public policy. I've just decided to take everyday examples so that we can think, we can appreciate, because I've noticed that there are so many people of different backgrounds here. So everyday examples that we can appreciate. Now, that brings us to the two main forms of it. Vanessa, any question? I can't see any questions. Okay. So then we have the sharp and then what we call the fuzzy. So sharp, as long as so you are either treated or not. So 0 or 1 probability. So you are the cutoff, and then you are to the right. So yeah,
Sorry, there's a question in the chat. I just
okay.
saw it. So Ebenezer is asking, I would like to find out whether the DDEP in 2023, I don't know what DDEP is. I don't know
Yeah,
the
yeah. The
unit.
debt, I think the national debt policy in Ghana, the debt
Okay,
management policy
it
probably.
says can serve as a cut-off line to understand stock behavior and its effect on portfolio management and risk analysis.
Okay, so what the treatment group would be, so for instance, if it is possible to clearly determine whether or not someone should have had a certain level of income before they fell into the DDP. So for instance, if you have savings of, let's say, £500, 500 cedis, for instance, anyone above that would have a reduced or debt repayment over a longer period. If we can clearly allocate that, then you can say that you can use an RDD. So then that becomes a sharp 0 or 1 or a fuzzy, right? So as long as you're above 500, the probability of falling to DDP increases. So then you are looking at a fuzzy RDD design, right? So
Thank you.
the most important thing is that he's able to clearly show that there's treatment that splits people into treated and untreated and gets a good control group.
All right. Thank you. You can continue.
Okay, thank you. So that's basically the sharp and so sharp 0 or 1, fuzzy, the probability that you are receiving treatment increases. And then that gets us into IV kind of. All right, so let's look at the sharp. So I'm going back to those basic ideas. So there is legal access to alcohol at the age of 18 in the UK, right? So let's say we assume a treatment variable DA, right? which is equal to 1 if you are above 18, and 0, you are at or above 18, so greater than or equal to, and 0 if you are below 18. Right, so that allocates the treatment. Now, so what that means is that once we know your age, we can know whether or not you are treated. So then treatment status becomes a deterministic function of A. But it is also discontinuous of A. So no matter how close you get to the age of 18, you're not treated until you turn 18. So those two things hold. And the second one then helps us understand the idea of no manipulation. So you can't push someone above because they are close. So now A becomes the running variable, which determines treatment. So in terms of simple expression, then the expression will look like, so let's say MA is the death rate in month A. So month post, month post 18, for instance, right? And then the treatment becomes DA and YA becomes the assignment variable. So we are interested in this row, the estimation of row. But this is simply like having a dummy because it's 0, 1, you treated or not. So what makes it RDD and not an FE with a dummy, for instance, or maybe a simple OLS? It is because we could consider a bandwidth, and our interest would be not in the entire allocation to treatment or control, but allocation to barely treated and barely not treated. So that makes it different. Okay, so this is a basic expression that we could have. Now, you can see that here I do not have any controls. So are we likely to have any omitted variable bias issues? That is, if we don't have any controls, if we are not controlling for anything, will the regression be good enough? Now, we've already described that the characteristics of the people around should be the same. As long as that is the case, then we do not have any issues of omitted variable bias. It doesn't mean we cannot or we should not control for other variables. The important thing is whether or not the effect you're examining for is explained by a linear function. Right. So for instance, here I'm just saying that the relationship is quite linear. If that is the case, then the linear specification is all right to explain what is happening in MA. Okay. Now let's look at another picture. So I've talked about a linear discontinuity. So for instance, here you can see that there's a jump. We are plotting that linear relation. So there's a running variable and an outcome. This is just arbitrary. So just something that I came up with. So not from any data, right? So you can see the jump here. Now in a nonlinear one, you can see that there's a curvature somewhere there. So basically, what does that mean? You should first look at the characteristic of the data you're examining first, right? It is easier to fit linear, for instance, if you are able to do an RDD not in a so big sample size. But if you have a bigger sample size, then going linear may be problematic. So then what you have to do, you have to plot and examine the data before you do that. However, you could be deceived that there is discontinuity when there is actually no discontinuity. So here is a nonlinear plot, but if we can see, we can draw these lines through and it will give us a straight line connection with the observation here without a jump. So although this is showing a kind of a split, this is not a discontinuity. And that is why we must examine this before we try to, to, to use RDD, because the story is based on the jump. We say there's a jump, so there should clearly be a jump. So what do we do? You can model nonlinearity directly, or you can just focus on observations around the cutoff. So what do we mean? So from our initial specification, we just add a square term. So you can use polynomials, you could go up to 4. Mostly that's what people do, right? So you can add square terms. There are different ways you can modify this. So you can introduce different running variables. So for instance, you can say that you are centering A. So subtract A from 18. So the age from 18, and then you center A, and then you can then test for those that are just below and those that are above. So you have different estimation points for those above and those below. You can combine that with an interaction term. So basically, the linear form becomes the foundation for whatever RDD you are doing. But there are no general rules around whichever model that you use. However, they should speak to the graph that you have. So the likelihood is that if you have a quadratic graph that clearly shows discontinuity and have a smaller sample size, a linear RDD estimation would not be problematic, for instance. Okay. Any other questions so far?
Yeah, there was a question in the chat. So Emmanuel is asking that, let's say for the alcohol example where
Mhm.
you can take alcohol at the age of 18, how will you determine the bandwidth in that example? Like,
Okay.
I think generally speaking to how to determine
How
bandwidth.
determine that? So once you do the plots, the bandwidth come with it. So sometimes it gives you an estimated bandwidth, for instance, right?
All right. And
Yes.
just now, there's another question. You can pick this and continue. Sorry.
Okay.
So the Sushil is asking, how do we know if it fits linear or quadratic RDD better?
Okay. So like I said, once you do the plots, and we'll go to some of the plots when we do the applications, right? Now, the easiest thing to do that would be first to do a polynomial plot to establish that there is discontinuity. Okay. If you don't, you could do a linear plot to establish that there is discontinuity. Now, if you do a linear plot of your data and you find discontinuity, then you have to do a linear estimation. If you do a quadratic plot and you find discontinuity and you have a smaller sample size, you could do linear and there would not be any problem. So like I said, there are generally no rules as to which one is better. So what you'd find with that RDD in most cases is people go with the one that gives them the best results, given the sample sizes so it's better when you have large data set to deal with. But if you don't have large data set to deal with, then that becomes limiting finding even discontinuity to start with before you determine what model to use. Okay. So the second way to deal with what we just saw would be to include a bandwidth. So what would be the bandwidth? So let's say a point B such that those below and above. So for instance, let me give you an example from the elections. You are looking at political behavior given that a particular local government is aligned or not aligned, and you call close elections. How do you define close elections? If you say that an election is close if a particular party won by 30% or lost by 30%, that is not close. That is almost a pure majority, right? So then you must come to as close an election as possible. So for instance, 10%. So if you are lost it by 10% or won by 10%, that's a close election. So you could even go further. As long as you have a lot of observations around, let's say 2% electoral victory or 2% electoral loss, that could be your close. So as you go on, I'll plot a histogram so you can see what I mean by that, right? So 2%, that's quite close. And then you can do what people do. You can multiply that bandwidth by 2. So 2 on each side, 4 on each side, or 1 on each side, divide by 2. So you can get even closer. So the bandwidth itself, half the bandwidth or twice the bandwidth. Or comparing those that are just treated versus those that are just not treated. So if you have more observations, then you can even go closer and closer. Okay, so that's it on sharp RDD. So fuzzy. So I think Emmanuel asked that question. With Emmanuel's question, you're looking more like a fuzzy RDD. So for instance, if let's say you had a savings of 500 Ghana cedis, that was a cutoff into whether or not you are given a DDEP or not. There are likely to be several people above that, so the probability of getting to DDEP would vary around that. So then that gives you what we call a fuzzy RDD. An example would be the age of retirement, right? It keeps changing. So you could be in a job and then it will change. People's decision could also vary depending on the change. Some could decide that I'm retiring now or I'm even working more. But that has implications on your income and the retirement funds that you receive, for instance. So if they add more years to it, that could mean you have reduced retirement funds. If they reduce it, that could also have implications. But the decision to go on retirement would vary given the differences in ages around the cutoff. So then you have a probabilistic allocation into treatment rather than the 0-1 decision of treated or not. So then that gives you a fuzzy kind of RDD. So let's look at the differences. So for instance, in a sharp, you could have the cutoff with those to the left treated, those to the right not those to the left not treated, those to the right treated. When it comes to fuzzy, there are those to the right, but the probability of treatment would change. So it's not a simple not treated treated, but the probability of treatment will change. That is why in fuzzy, sometimes people use that as an IV for the treatment itself, an instrumental variable for the treatment itself. Or you can use that with interaction terms as instrumental variables. So you have a first stage regression with that probability on the treatment and then the treatment in the second stage regression. Okay. Now let's come back to controls again, what we call covariates. If all the assumptions we've discussed so far hold, then all the observed and unobserved covariates are balanced. We are saying that the characteristics of those to the right and left are the same. So we don't need to include them. But you can still include important relevant confounders. So for instance, in my paper, which we'll discuss soon, You see the results. You included controls, but you do not find results for the controls because they are not really relevant in our case, given the assumptions that we made. And then you can include interactions. You can complicate the model as much as you want beyond the covariate itself, right? But what could be some of the challenges with RDD? So for instance, assume that people know the assignment rule in advance. Let's go back to the hospital example. So people sit in a consulting room and then we say that, oh, there's a particular treatment that is coming. If you are in group A, you would receive the treatment. If you're in group B, you would not receive the treatment. What do you think would happen? You are likely to find an empty group B because everybody, if they need the treatment, will run to get the treatment, right? So if the assignment rule is known in advance, that could be problematic. I mean, for the assignment, right? If people are also interested in adjusting the rule, like I mentioned the example of getting into a school, if teachers manipulate the marks students could get, that could also be problematic. If the cutoff also depends on other factors, so a person's decision to drink at age 18 depends on whether or not they have friends, strongly depends on that, then becomes endogenous. That could itself be problematic. If you have a few people around a particular, so for instance, if doctors, for instance, rush to give treatment, as long as you have a systolis of 135, then you can have a lot of people around 135, 136 receiving that treatment. So you have what we call heaping around the running variable. That could itself be problematic. That could be a challenge. So how do we deal with these challenges? So we have what we call the manipulation test, where we plot to see whether or not actually there is treatment to start with, but to deal with the first one, that the assignment is random. We can do covariate balance check. What that means is that if we estimated, sorry, the treatment variable on the covariate, we should not find significant results. So they should show no discontinuity. That's a basic way of, and there are other ways you can do it, other placebo tests that you can do. Dealing with heaping, we call let's say the donut hole. So what you can do is that you can drop the observations that heap. That's an unconventional way of doing it, but that's also one way of doing. So we call the donut RDD, and that'll be one way of dealing with heaping. So you drop those observations, and then you construct a new cutoff. Oh, sorry, you drop those observations, and with the cutoff, you look at your bandwidth and estimate. I think. Vanessa, is there a question?
Yeah. So Kingsford is asking, do matching and weighting technique find its way in RDD when there's some form of covariate imbalance?
So I would say in a fuzzy RDD, yes, because of the probability treatment. But in a sharp RDD, you may not need to wait. Kingsford, is your question answered? As if he can speak. Okay, great. Okay, perfect. So basically, that's my basic introduction to RDD. No complex estimations and econometrics. I hope it wasn't too boring for the the econometricians around, but it was accessible to the non-econometricians. Right, and these are extra readings that we could benefit from. Right. Let me stop sharing. Do we go straight to the application?
Yeah, if there are no questions. Okay, I think someone just placed the question in the chat. So
Okay.
Maxwell is asking if the intervention is rolled out across groups at different points in time. Um,
Oh.
is is it possible to combine RDD with other staggered DID methods? Interesting.
Ooh, that's interesting.
Yeah.
Maybe you have to help us find an estimator like that. Yeah, yeah. But I mean, it's things are getting interesting on that front at the moment. So I'll not be surprised if there's an estimator already for it, because all these ideas that I shared were people saw through dealing with problems that have become solutions at the moment, right? Because if it's target over a period, okay, okay, let's leave it here. I was trying to just analyze the process of allocating probability of treatment and whether or not people would be able to sort into treatment. So within in the next period.
Mm,
So if you are using age, for instance, or you are using the same medical treatment, for instance, is it possible that I could turn a certain age, gain a certain wage, and then become someone who would need treatment? So I'll move from not treated to treated in the next period.
mm. Yeah, and I think someone is asking if you could show the extra reading slides
Sure, sure, sure,
for us
definitely,
again.
definitely. Um,
But the slides would be made available, so
yeah, yeah. But I would say that these are mostly what I'll call good ways of doing readings on topics like this outside of complicated theoretical approaches. So I would say that as a PhD student, machine metrics and mostly harmless econometrics were like my go-to Bible. You could read it while sleeping without picking anything to solve anything, right? Because they are not as complex as you find. Kingsford is laughing. They're not as complex as you would find a typical econometric textbook. So causa inference mixtape, for instance, you can read it on a train, on a bus. Mostly harmless, you could read it anywhere. Unlike taking a typical econometric textbook where you would have to uh, do a lot of complex stuff. My office mate is a theoretical econometrician, so I know the kind of books he works with. So, right. Any other question?
I think you can move into like the application, and if there's
Okay,
any other
great,
question, they would
great.
put it in the
Oh,
chat.
great, great. So the application, I'm basically going to discuss, and Vanessa requested. So let me say that what I'm going to do was on the request of Vanessa, so on the application. So basically, there's a paper that is currently published it's for my PhD, and it's on political alignment in Ghana. So the idea is this. Um, you are looking at local governments, and we say that the local government is aligned with the central government if that local government votes for the party in power. And if they don't, it is not aligned. How do we determine alignment in our case? So, for instance, if the MP in that particular local government A is in the same party as the party in power, then that local government is aligned because it means that they voted for the representative of the local government. If the MP is not, then the local government is not aligned. Why do we use MPs? Because in Ghana, we have what we call the district assemblies. And all district assemblies have members of parliament represented. Those are not just represented at the national parliament, but they are also participants in local government because they are members of the district assembly council. So they have interests both at the local and the national level. So we use MP affiliation, right? If you are looking at years of, okay, I'll come to that side. Then what is the outcome variable? We say that given that you are aligned or not, are you punished as in terms of allocation of central government grants? So in Ghana, grant allocations are formula based. So it is non-discretionary, right? But what goes into the formula is discretionary. So parties can manipulate the content of the formula according to their interest, such that between any 2 years or between any two regimes, one local government could receive more grants relative to another. So for instance, within the formula, there's an allocation for what we call so for instance, if you have higher population, so resource use, if you have higher population, there's a higher likelihood that there will be congestion. So public facilities would have to be replaced often. That is more likely for a district that is rich, and that is more likely for an urban area. Now, if you have a party that has more of its vote from the urban area or more educated people, right? If they manipulate the formula to allocate more to that particular part of the formula, then what that means is that they are basically indirectly favoring their supporters. So whilst the formula itself, I mean, the allocation itself is non-discretionary, because you can manipulate the formula, it has an alignment effect within that formula itself, within the allocation. What that also means is that at every point in time, if parties are able to judge local governments that voted for them and those that didn't, then they are able to influence outcomes, right? So there's a particular, for instance, part of the formula that's based on needs. So things like doctor-patient ratio, school blocks, and things like that. So that would benefit a rural local government. If I lost all the seats from the local government as a party in power, I could allocate more to that and get them on my side. I hope this explanation makes sense to us. Then what that means is also that if that local government is receiving more revenue from the government, they are less likely to raise more of their own revenue. So for instance, if local government A is taxing its residents, the residents see how much tax they are paying, right? So that has the implications for their support or not for the government. But if at every point at a particular point in time, sorry, the local government receives more money from the central government, then they do not need to tax their residents to provide the same public goods. Right? So then in that case, if they're receiving more, they are likely to raise less on revenue. That has implications for spending. If I spend my own money because I'm to go back to the people and account for it, I'm likely to be prudent. But if I'm spending money from the central government, because I do not tax my people for that money, I'm less likely to be prudent. So I'm likely to have a higher spending behavior. So what we do is that you're looking at the effect of that alignment on fiscal outcomes. So what I call revenue expenditure, own revenue generation. That's basically what we do in our RDD estimation. So I'll not bore you with the results. So that's basically the idea. So how do we implement the RDD in this case? Okay. Let me share my other screen with you. Can we see, sorry. Can we see the Stata? Great. Okay. Now, before I go to that, let me just explain the basic steps in implementing an RDD. I hope you can see the do file side too, right? I'm sharing a different screen now. Can you see? Oh, okay. Can you see that?
Not yet.
Okay. Can you see the do file?
Yes.
Okay, great.
Yes.
So to implement an RDD, the basic steps would be first, you have to explore the random variable. So you plot, you do a histogram plot. In our case, the random variable was margin of victory, right? So margin. You explore that random variable. So you have a histogram plot of it to see what it looks like. Then you test whether or not there's manipulation. Sorry. So you do an RD plot of the outcome versus the random variable. And then you do the bandwidth selection. Once all these have been done, then you go straight to estimating the treatment effect. And then you can go through some of the robustness checks that you will do. But if you have a Stata, so if you're
Um,
using Stata, yeah.
Prof. Obeng, can you please maximize the font like a bit?
Okay, okay. Uh, oh,
I think Vanessa. Okay, sorry.
yeah, go on.
I
Please
was
go on.
suggesting that they can maximize on their screens, but you can also do it. I I don't know.
I don't know how far I can go again.
Okay,
Uh,
I think it's fine then.
okay. Can they see it now? Oh, yeah. Uh, is it better?
Yeah. Yeah. Thank you.
Okay, great, great. So what I was saying was you explore the running variable, right? So you plot the histogram, of the running variable. In our case, was margin. Then you do a density plot to check for manipulation. Then you do an RD outcome variable check to visualize the discontinuity that you're interested in. And once it is clear that there's discontinuity, then you can estimate the effects, right? Then you can go on with other robustness checks. So, but to do that in Stata, you have to install all of these packages. So these packages are available online for free. You can just ask Stata to install directly, or you can let Stata do it from online. So that would basically be the basic approach to it. Okay. With that said, let me then go to sorry. Let me go to what we did. Okay. Can we see the new screen I'm sharing, which is the data? Or is it too small here too? Okay, 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 great. You can see that. Okay, now, so what do we do first? So in our data set, this is what our data looks like. I'm going to collapse a lot of it soon. So we have our outcome variables. So this is the full data set. I think this data should be available on, oh no, it's available upon request. So it's not, but the do file should be available online. So this is the entire data set. So you can see various variables, the IGF, grants, revenue, expenditure, CPI, because you wanted to do in terms of real per capita. So enrollment rate, control, and total enrollment and population were our control variables. And because you did per capita, so then we have damage for election. So not all these, so this is the entire data set, but not all of them are relevant in our case. So basically that's the data, right? So let's do a histogram check of that. So I hope because it's on two. Okay, good. So what we can see is that at the cutoff, there are observations around here. Can we see the graph? Great. Now, this was what I was talking about. Because I have a lot of observations closer to 0, I can have a smaller bandwidth. Generally, my observations are not many per RDD standards, but they are large enough for what I want to do, right? So I can have observations around here. Now, if we're talking about heaping would have been a case where, for instance, all these observations were somewhere here or there. Okay, so this has told me clearly that my cutoff splits the observations to treated and not treated. So that's the first part of it. Then the next thing would be to do my RD margin plot. So in the paper, we remove all these things around and just leave the red and blue line. So it shows me that I'm not manipulating the discontinuity. Now, RD density is a more modern way of doing this, right? There is the McCrary test, which is also a manipulation test. And today it decided not to work for me. My other files are not working. So I thought, let me just stick to the modern one, right? So this would give the manipulation test. So it shows me that basically I'm okay. Now, this is for the running variable margin. So in the paper, we do RD plots for the subsamples. At this, okay, probably just to align with the paper, let me just go on and then do what we do in the paper. So in the paper, we split the entire period into two. We look at periods before and after the elections. And this was upon advice by a reviewer. You know, reviewers always ask you to do things at the end of the day. So we split that just to see if party behavior changes over time. So you can look at party behavior across their 4 years. That would be different if you looked at their behavior just when they got into power and just when they were getting close to elections. So that was what we did. But typically, if I was doing an RDD plot for the entire sample like this would look something like this. Right? So this would be the RD plot for the entire sample. So we can see the discontinuity at this point. Thankfully, and you can see that the polynomial order is 4. Thankfully, it may not be obviously, how do you call it? It will not be obviously discontinuous, but it's discontinuous enough. Okay. Now I'm torn between using this or collapsing the whole. Okay, let me collapse so that we look at the estimates. Okay. Maybe someone is looking at the paper itself, so would want to see that my codes are replicable. All right, so what I've done basically now is to collapse the entire data set to years after. So the first 2 years after the elections. So that's what I'm looking at the moment. All right, so with that, I then need to go back and generate my variables. I mean, I'm doing these really fast because they're not relevant to the RDD, right? So I've generated all my relevant variables. Now let me estimate the RDD. And these are my results. You can see that there are 3 sets of results. This is D, which is the cutoff, the bandwidth, 50% of it, and twice of it. So our bandwidth was, I think, 2 and 3, and twice of it, no, it was 4 and 6. Twice of it was 8 and 12, and then half of it was 2 and 3. So we're really close to elections. It was a really close election, if I should say. So you can see that when I look at the actual cutoff or the bandwidth, I find significant, almost significant, but I'm safe results. And half of that are also significant, but then twice of the bandwidth. So what that means is that I should rather be looking at really close elections. That is what this is telling me, and this is for grants. Let me estimate it for IGF. That looks great. But it also tells me that I should be looking at really close elections. So what does negative means? What we are finding is that alignment, so being on a party side, rather causes the party to focus on those not on their side. Because they have already won your interest, they are looking out for those that are not on their side. So they would rather be targeting swing voters. But remember that this is very so for every voter that just voted for the party in power, the party in power's interest will be in the every voter that just did not vote for them. That is another way of looking at it. And then let's look at expenditure. Here also, it's clear that we are looking at close elections. I mean, the others are just estimations for all the others that you're interested in. So we look at, for instance, over the entire period, there were districts that split, and then we are looking at the effects for the split versus districts that remain the same. We are looking at districts that have just one MP versus those that have more than one member of parliament. So that's what we considered. And we also found that within the period, there were periods of fragmentation. So we dropped, like I said, the district that split. We dropped all the years that there were fragmentations to see if the effect would hold. So those were other things that we did. Now, I would like us to consider the placebo effects that I was talking about. Okay. As you can see, the RD effect in each case is not significant. Probability is here. So then what that tells me is that the covariates are continuous. Now, another reason why I think I should have mentioned this, another reason why we could do an RDD on the districts. So is that we say that they are homogeneous. They have similar administrative, political, and budgeting characteristics. Right, so administrative, so their structure is the same in terms of whether or not the mayor is elected, the number of people that could be in an assembly, how it is determined, 70% voted, 30% appointed by the president. The other thing is on fiscal levels, they have the same responsibilities, right? They can raise revenue, they receive grants, they can spend. And then the forms of revenue that they can raise, if you go into the specifics of it, you can have rates, rents, and all those things. Their responsibilities are the same. They are responsible for basic health care provision. They are responsible for basic education, sanitation, and basic economic development. So you can do an RDD on them. That's an important consideration that I should mention. So basically, that is an RDD done in theory and in practice. All others are just additional results. Yeah, Vanessa?
Yeah, I think when you touched on the placebo, you mentioned something along the lines of covariates being continuous. I would want you to like explain what that
Yes, good,
meant. Yeah.
good. So what we are saying is that, let me do a balance test. Good. Thank you for bringing me to this. My covariates were population and enrollment. So look at an RDD of margin on population. You can see that the estimation is not significant. So that satisfies the condition that I mentioned. So it's important to have a balance test. These things are usually done pre-estimation, but they're always posted in the appendix, right? But they are done just to firmly convince everyone that what you're doing is right. So there's no manipulation. Your covariates are continuous. So in this case, I could even drop them if I wanted to. Any other question from anyone?
None so far. I think you can continue.
Okay, I think I am done. What I have to do would just be going through all the other results in the paper itself, which would not be too different from estimating these outcomes that I have estimated here. So basically, to go through again, let me just share the practical approach to doing the RDD. So first, can you see my screen?
Yes, please.
Great. So first, you would have a histogram of the running variable itself to see whether there's heaping, whether it's well distributed around the cutoff. Then you do an RD plot of the running variable to check whether there's any manipulation. You choose the bandwidth. You'd have to also do an RD plot of the running variable and the outcome itself. I think I have one somewhere that I did. Good. I did RD plot of grants and margin at some point. That showed just to show that yes, there is a discontinuity. Then you have the boundary selection. You can go through the boundary selection process. And then after that, you can do RD robust estimation using the outcome and margin. Like I said, here you can do a linear, you can do quadratic, whichever one that any polynomial that you would want to use. And then you do various robustness checks. You can change the bandwidth. But like I said, if you, for instance, did what we did with our RD estimation that gave us all the 3 levels, then you have the bandwidth, it's by half, and then twice that. So basically, that's the practical approach of going through RDD, which I believe is quite attainable. And I would say again, I think it's the simplest of all the causal inference approaches.
All
So,
right. I, I think there's a question in the chat.
okay, yeah,
So, Emmanuel is asking if IGFs are budgeted and spent by each MMDCs and has no affiliation to the MPs in PowerNet. What
okay,
is the justification for its estimation?
great, great. So this is the idea. Going back to it, you are aligned. Or all districts, let me start from this, all districts receive grants from central government. Those grants have implications for their behavior. If I receive grants, then I have a less likelihood. And so if I receive a lot of grants, then there's less pressure on me to raise more IGF. So for instance, I do not have to raise market tolls at the local level because I'm receiving, and I should say that even for Accra, 60% of AMS revenue come from the District Assembly Common Fund, as we call it. And for some local governments, they're almost 80 to 90% dependent on central government grants. So that means is that what that means is that they are raising less of their own revenue because they're highly reliant on central government grants. The problem then becomes if central government is able to allocate more to its own people because of alignment, then it could make its own people lazy even more and not raise more of its own revenue. Somehow, SAP could describe this as flypaper effect in the theory, right? And that one you can estimate that with fixed effect. So what we are basically saying is that if I'm receiving, if there's alignment, how does that affect how much grant I receive? How does that alignment affect how much revenue I raise on my own? How does that alignment affect how much I spend? Remember that within that same grant, there is also what we call the responsiveness factor. I think I should have mentioned this. What that speaks to is that if you raise more of your own revenue, you allocated more grants. So there's within the formula an opportunity to receive more if you raise more revenue. So there's an incentive. So by doing the alignment effect on grant, you're also, sorry, on IGF, you're also in effect looking at whether the incentive effect is positive. Emmanuel, does that answer your question? Great,
Yeah.
thank you. Great, thank you.
Any other
And
question? Well, if not, thank you so much, Prof. Obeng, for making time to be with us today. We would allow you to share some few thoughts with us as early career researchers as we're upcoming. Anything you would like to leave us with in terms of publication, in terms of anything, in terms of even our grooming. Yeah, we're glad to hear from you.
okay, thank you very much. Let me once again say thank you to Vanessa and to Kingsford for the opportunity. I would say that especially for those in PhD, I'll come to all of this. Um, there's room to enjoy PhD for a few years after PhD. Well, those who want to come into academia, for instance. So what I shared came from my PhD, but the data sets that I constructed, and Vanessa, I think you've seen a bit of it, I continue to construct it, and it has led to 3 other projects out of it. So build a pipeline on your ideas. The data, it took me 1.5 years to put together the data set for this particular publication. Part of it was on someone's in Ghana pen drive. I got to the ministry. We lost a whole year's data because someone lost their laptop. And so the full data set that I have, the ministry does not have my full data set because they shared it a few years ago. So an early part with someone about 15 years ago, and they lost that part. So I had to trace that individual to get that early data set, add it to what they had then, and continue building. Fortunately, now most of the data set is online. So every year, I have RAs working with me that we update that data set. And because of that, I have ongoing projects. So basically, your PhD could be a pipeline. Um, for those that may also be us again to PhD and those that may also be going on the job markets, there are different pathways in academia. Probably in the UK, I know in the US and Canada, they have similar things. So my role, I am a teaching focused assistant professor. But the difference is that it is 30% research, 50% teaching, and 20% admin. I'm expected to get grants. I'm expected to publish good. So I have the same research commitments like someone so at Warwick, like someone, let's say, in Manchester, for instance. Right? But because I love teaching, I'm not in a teaching focused university. I'm in a research focused university, but I'm able to do my teaching. And what teaching do I even do? I just lead 2 modules and I lead 2 seminars. Basically, that's it. So it's not really a huge teaching load. So just to say that open your eyes to different opportunities if you are considering academia and different roles in different countries. I think Canada, they have a greater teaching load on those. And then in the US, if you are going on that path, it has a greater teaching load. So probably the UK might be different for you. The job market for academia is getting difficult, and I think we are all aware of this, those in the PhD. But it's never too late. I'm happy to advise and guide if you have CVs and things like that. And I'm also hopeful for any collaborations if you'd want to. Generally, for every other person, let me just describe my background. I did my undergrad and master's in Ghana and came on to my PhD in the UK and ended up in Warwick. So just to say, whatever training we are receiving, wherever we are, is good enough. Especially, I'm talking to my Ghanaian friends in this case. I worked as an RA and a TA for a while. Interestingly, I sat in the same class with Isaac at the undergraduate level. So Isaac and I were undergraduate mates, were teaching assistants together. So whatever training you are receiving, don't belittle it. It's good enough. That's what I would say on that side. What again should I say? On advice, publications, quality is better than quantity. That is the lesson I have come to learn. As a PhD student, I was eager to publish more. But as I am growing, I've realized I have to publish well. So if you can do just 2 or 1 in a year that are of good level, it is better than doing 5 that will not contribute to anything or progress, especially those in academia. At least I'm speaking because I'm in academia. That's what I know much about. So quality is better than quantity, and that takes a lot to get. And collaboration works well. Find your strength, find other people's strength, and work with them. One of my co-authors, she's a specialist in spatial econometrics. Yeah, we are working on a paper in spatial econometrics. I've basically left that side to her because that's her strength, right? So that I can focus on it. That makes it easier to work on quality things, although it would take longer. So collaborate, network. I am so glad. I mean, seeing this, I was so glad that we never had this opportunity where we could share ideas. But I'm so glad Kingsford and Vanessa is leading this. So collaborate, build on the networks that you have, and try and reach out to people, and that'll be it. I think what I'm saying is basically academia. But if anyone has a general question, I'm happy to answer.
Okay, we are gonna open the floor to take one or two questions before like I end with announcements, then we leave. So please, if you want to ask a question, you can just raise your hand. I'll call you, then you can ask your question.
Interesting. Hi, Debbie. I think I remember you. You're doing your PhD in the US, right?
Yes, yes, I am.
Great. Yes, I think I remember you. Good to hear from you.
Same here.
Right.
I think two question is coming. So can you hear me?
Yeah, sure.
Yeah. So I
So,
would want. Yeah. Mine is on the aspect of quality versus quantity.
mhm,
Um, I think our session right now is interdisciplinary. We have people from policy, people from econ, people from
mhm.
sociology, political science, and you know how the paper timeline varies.
Yeah,
So I would want you to dive deep into throw light on the quality versus quantity, the duration,
the
ideas that should, linger enough. I don't know if the question is clear, but like
yes.
your collaboration with people from different disciplines, what would be your advice? Because it looks like if you're not careful, you might be stuck on one project for 5 years, like the econ timeline, and yeah, that's I don't know if my question makes sense. Yeah, thank you.
That's true. That's really true. So, for instance, the journals you're targeting, as you said, determines the timeline, right? So, the quality is in the idea itself. So for instance, if you are using a method that uses RDD, it should be good. It should be a clear discontinuity, and then you can have a good outcome from that. Now, you may not get into AER, for instance, if you are in economics, but you could get into Journal of African Economies and very good journals. I'm not saying that they are not good, very good journals. That could take longer in econ. Quality in other places could take 3 months, 6 months. But the advice would be that you are not sticking to, for instance, always doing fixed effect estimations, easier to examine methods, right? Like you are not known for only one method or approach over a period, but you are varying and showing improvement, right? So, for instance, if you are a qualitative person, is there an opportunity to collaborate with someone who has quantitative um, background to do something better than, not be, sorry, something above the qualitative that you do too, so that you have something stronger to back it up? Are the topics you are researching recent enough? Is the data you're collecting challenging enough? Are you bringing in new ideas? Those things are on the quality level. Of course, even, for instance, this project started in 2018. It was published, it's 2023. It took a while. After a few rejections and one rejection was the editor came back to tell us that our review looked different from the original paper, but it was based on the comments that you gave us anyway. So in econ, it could take longer. In computer science, it could take shorter. But what I'm saying is that the topic should be recent, the method should be a little bit advanced, the collaboration should be more, and then you should be building on your repertoire, things like that. I don't know if Kingsford, I fully answer your question. I've answered your question. Yeah.
Before I let Emmanuel come in, you touched on something which I think, especially since I've geared towards the policy domain, about the method aspect. I think you've already touched on it, but I don't know if you would just hammer on it. You see, it looks like it's more of like showing how rigorous or how sophisticated and fancy, quote unquote, the method is, as opposed to the field I find myself in, which is more of like the questions they're asking. And I like you touched on that, but I don't know if you would want to throw like so that it would just be like, okay, how do I bring a new method after my first paper?
Okay. Thank you very much. There's room for both, right? So I've spoken to a few in my department. I have quite a few editors here. It's also the question is it's become very important. The question and the data itself, right? So if the question is a good question and the data is unique, sometimes the only way to examine the data will be a fixed effect, for instance, not a fancy RDD or a DID. But because the question is good enough and the data is good enough, you would still get a good publication. Right? So it's not always about the fancy method. Sometimes the fancy method even puts people off because you overcomplicate the method. Right? So a good question there. But I mean, we just have to keep trying. But I think a good question and a good data always helps.
Thank you
Emmanuel?
so much. Yeah.
All right. Thank you very much, Samuel. So
Mm-hmm.
my question is about data.
Mm-hmm.
I had a qualitative background. I did my undergraduate in history. I'm currently doing a PhD in public policy, and I've
Mm-hmm.
been introduced to all these quantitative methods. I want to apply them, but most of my questions are like racial question related to Ghana. And my biggest challenge has been data. You go to government websites, sometimes you feel like you have something going on, like a little bit of good data for maybe a year or two, then the rest, maybe you need a longitudinal data, then you don't have that one. Yeah. So how did you like? Last year I was trying to work on something on the evolution and decentralization. I wanted district assembly data like you worked on with this paper, but I was really struggling to get the data. It looked like I had to build it myself, but even how to was a challenge because you get the data, like it's like you have to extract the budget statement of each of these districts and collate them one by one and do that over a long period of years. Sometimes some years are missing, some districts are missing. So essentially I'm just asking, like, how are you able to overcome these data challenges, especially if your research is largely centered on Ghana or most of these African countries?
Great. Thank you. So you are speaking to my challenge. Thank you very much,
Yeah.
Eva. Like I said, this particular research, it took me 1.5 years to put the data set together. Part of it, I collected from previous researchers. The other part, I went down to the ministry to collect. The final part of it, I manually computed or calculated from the Ministry of Finance website when they started putting the budget online. So when I went to the ministry, that was when they had considered putting it online. So I was given books of district assembly budgets to come and scan on my own, PDFs to scan on my own. It's a challenge. So as a PhD student, I had to construct the data myself. Like you're saying, from the budget itself, there's a lot of information there, right? But you have to manually do it. What some of us have decided to do is that over time, we are trying to make our data set public. So I've been building, like I said, every year I have RAs working with me to continue building the data set. We can only do it to help ourselves and others. Unfortunately, Emmanuel, you might have to manually put it together, right? So that you would benefit from it over a long time, and then we can help others. Sometimes you may not be able to answer the question over a longer period of time, like I have been able to from 94 till date. You could be limited to 2020 till date.
Okay.
Or even more than, even less than that. Work with that particular data set. That is why it is for a PhD. Then build on that data if it is still of interest to you as you go for it, like I have done. Right? At the moment, I'm expanding to 2024, 2025. So that's the advice I'll give. But it would be challenging. I worked on a project on Kenya with an undergrad student. She had to collect the data for us, manually put the data set together for us because she was Kenyan. So that's the challenge. That's the challenge we have. And the interesting thing is, let me say, Ghana is better. That's where I'll end it.
All right. Thank you so much once again, Prof. Obeng, for being so generous with your time. We are
You
so
too.
much grateful for the insights you've shared with us, for the word of advice. And for anyone on the call who would want to engage with Prof. Obeng outside of this very webinar, you would have access to his email, which I
Yeah.
think would be in the slides that would be shared. And I'm pretty sure
That
he'd be
reminds me.
open
I
to.
didn't put it there, so let me put it there. I will put it there, sorry.
Yeah. And I'm pretty sure he would be open to entertaining emails and discussion or queries from any of us. One last announcement before we leave is on the call for papers. So Quantbridge has opened call for papers, I think, which we intend to start this fall, and the deadline is August 23rd of this 2026. Yeah. So if you're a student in public policy, economics, sociology, and related social science discipline, you're encouraged to kindly send in your paper. And you don't need a full paper. You can send just an abstract with preliminary findings. So please, we are all encouraged to send in our papers. If there are no other comments from my host, I think we would be ending today's webinar. Thank you all for making time to join and enjoy the rest of your day wherever you are. Bye.
Thank you too. Bye.